Hello, Internet. All right, I want to show you today what I've been working on the ultrasonic distance sensor solution. And if you remember my last video, there was a breadboard prototype on using the particle boron LTE chip with the HC SR04 ultrasonic sensor from Adafruit. And we were setting up a little connected system where we could see like how far away something is from maybe like connected dumpster, connected whatever, anything that needs to measure distance. So basically, I saw this tutorial, and that's how we set up the prototype. And now we want to take this prototype and actually make it something that we could create at a larger scale. So we want to, the first step is making a printed circuit board layout so we don't have this big breadboard mess. So quick thing to note here is we have this down here, this voltage divider circuit, which is where we have two resistors to drop the voltage at this pin. The reason we have that is because the HCSR04 has 3.3 volts or 5 at the analog, and so analog is 3.3 volts, but then digital needs to also be 3.3 volts. But the problem was we're getting powered by 5 volts. This sensor needs 5 volts of power, so we needed to do a little weirdness. Luckily, over here at Adafruit, this sensor it's $4, real cheap. This guy can be powered by 3 or 5 volts, so we can get rid of this whole voltage divider circuit. Alright, so now let's jump to Altium. Altium is some really sweet printed circuit board layout software. I want to show you the kind of the final product of what we have so far. And with this, this is the software to create printed circuit boards. We send these out, and we can actually in a week have the circuit board in. But you can see here, this is basically these dots are where these pins are gonna like go into. They're through hole components, not surface mount for this first experiment. And then these holes here is where the ultrasonic sensor. So it's gonna sit like this. Like this is gonna be the product, and it's gonna be like this little square thing. And then cool thing in Altium, you can see like when we actually get it manufactured, this is what the board is gonna actually look like with the pins, our mounting holes, and all that good jazz. And I want to show you kind of like how, so like the red line, this is the top of the board for like traces, for like instead of wires, these are board traces. And I want to show you like how this stuff even works. So let me actually delete this trace, I'll show you. So these lines are hooked up based on a schematic that we drew. So this is basically, we took the tutorial and we made it into this schematic. And then when we upload it into the PCB, now it says, hey, we need to route this pin with this guy. So you can come here, and basically this is how the routing works, and you're just connecting your dots. Interesting note on this route here, the red is at the top of the board, the blue, so like is at the bottom of the board, and you can have different layers. And the reason why is because you can't have wires cross. So like, these have to be at the top. Well, this wire has to be at the bottom of the board. So, like how this route works, we'll try this. Let's see, maybe not. Okay, so how this route works. What the heck? Let's see here. Delete that. Delete my via. Delete this. Okay, so and we can delete this. And we'll just interactively route. So we need to get this pin 1 of the ultrasonic sensor to pin 2 of the particle. So what we do, we come here in Altium, you click here, and so in here, top. Okay, so, but like we can't go over these two red ones. So what we do is we click here, and we come here, we go to bottom, and then this is called a via, this little thing, which means it's gonna allow it so we can go to the bottom. So we click via. And then now we take this blue guy here. Boom. And now we have a top and bottom routed pin. So that's how that works. Pretty easy. And then the next thing I kind of want to show is work backwards on how we even got to this, which is kind of interesting. So like I said, in Altium, what you do is you create your schematic first, which is very simple. And one of the complexities was we didn't have this component here, this feather, or this RCWL1601 ultrasonic sensor. So I created a library, and down here you can see We have a schematic library which has both parts, and all you do is you create this box and then you add like pins and you put the properties. So like there's an input pin, it's trigger, echo, ground, VCC voltage, and you basically just add the pins, and you say what they are, input, output, all that good stuff. And then you also associate it with a footprint, which we actually created. So if you go to PCB Library, this is the footprints. So this is the footprint for the feather, and we use the feather specification. So like footprint spec. The feather spec is very cool. It is something Adafruit came up with, and basically anyone that has that uses this feather footprint, which all of Particle products, all their flagship products do, basically the reset pin, they're all the same, and then it has the same like each pin is 100 thou or 100 mils away from each other, spaced, and then like this way spaced, it's 800 mils. So basically our job was to recreate that footprint in Altium, and they're associated with your schematic and footprint. So it knows like pin 1 is reset, and it will know that's the reset pin, all the analog pins and digital pins. So that gave us the building blocks that we could actually create this. And once we created this, then in Altium we did all that routing stuff to create our board. And so the next step is we're going to do a little bit more validating on this just to make sure. Like I have an issue right now that I didn't even know I had. Luckily, working with my electrical engineer dad, he pointed me in this direction, is I forgot these pins down here need to be plated. So basically, like, yeah, any pin that's going to have like a through-hole component needs to be plated. If you imagine there's copper in it. So I missed that piece. But that's a minor thing. So the idea is hopefully we will be able to, I want to order a circuit board. Hopefully maybe beginning of this next week. We'll order like probably 5 of them, and it's like $6 per circuit board, and it takes about a week lead time to get this guy in, and then we can put these pieces together and we'll have the circuit board done. And then the next thing is making a really nice kind of enclosure. So that's kind of the step on where we're at on turning a little tutorial prototype into something that's like more production ready for a connected IoT solution. If you're interested in IoT solutions, learning about this stuff, go ahead and hit the subscribe button. We're going to keep making videos as we turn basically an idea, a dream, into an actual full-fledged product, and we're learning how to create these IoT connected solutions from full stack. And the full stack is device, firmware programming, electrical engineering with this, to cloud software development, to front end. So like it's kind of the whole gamut of making a connected solution. So see you next time, and we'll keep moving forward with this product. Later.